I acquired the Aristo Revolution train engineer, the base station version. It has a part number CRE 57004, and I also augmented it with by using a relay socket and a hold-down bracket for using the optional pulse width control to linear converter. This is the Aristo Revolution 2.4 gigahertz trackside train engineer, the so-called base station. As to how I've implemented it, Aristo does not supply a housing such as this older 27 megahertz unit has, where it has a plastic housing and even a built-in fan that you could buy as an option. And so in this case I just supply this one circuit board here, and I elected to put a fan on it. It doesn't really require that because the improvements in the electronics is such that most of the heat dissipation can be done just with the heat sink radiator there. But in a confined space, which this might end up in, I thought it best to just spend a few more dollars and get a 24 volt DC fan. And that's what I've done. And I made these brackets here to straddle the circuit board. Brackets are about 9/10 of an inch tall. There's aluminum, one on each corner. So here's the pulse width to linear board, and I've implemented it by using a relay. And the relay, actually I've set it up to be controlled by the transmitter here. And there's what's called the auxiliary functions, and that's this connector back here. It's an auxiliary connector, and I happen to elect to use the blue wire, and that corresponds to pressing the number 1 key when the transmitter is energized, and I set it up for latching mode, so it'll actuate the relay. And I built this driver circuit here because the capability of the transistor driver, it's an open collector transistor that's inside, or you can't see, it's physically under the RF receiver board, but it's not capable of too much current. It's probably best to keep it around 10 milliamps, so I built this buffer or relay driver circuit here, which has a 3906, and basically, and I also put a indicator LED in the path that lights up when the relay's actuated, so I know if it's in linear or PWC just by looking at that. So the socket's very handy to put the relay on. There's a little metal bail to keep it secure, not that you really need to unless we're in a vibration atmosphere. So I bought this Meanwell 24 volt DC power supply. It's capable of 27 amps. You don't really need to have that much because this unit is capable of 15 amps, and that's why I purchased the unit primarily, because the old 27 megahertz unit was only capable of 10 amps. And in my setup outdoors, I discovered pulling grades, I like to use more than 4 engines, in which case I was blowing fuses on this type of controller. So this should give me a capability of using 2 more engines, maybe up to 6 GP40s, for example. So that'll help out pulling grades in my backyard layout that I'm still building. And this is the way I've implemented it. Again, there's an ammeter, happens to be a 30 amp ammeter, because maybe a 20 would be better, but that's what I could get. It has a shunt on the back of it here. And again, this Meanwell power supply is rated at 27 amps. You can buy one maybe $20 cheaper for 18 amps, which would be probably about the ideal for this setup. But I've always had the experience where I always seem to need a little more current, so I spent the extra 20 bucks and got the 27 amp supply. It doesn't have a switch, and you wire it up to AC, and it's as soon as you plug it in, it energizes within about a minute or less. If I plug it in here, and you can see this indicator come on, so it's now energized. The fan has come on. It's a 24 volt DC fan, and here is where the input comes in at the receiver. I can get the voltmeter on it here. like handling chopsticks. There it is, 24.3 volts. So that's what it's putting out. The power supply does have an adjustment on it, and there are extra 15 amp fuses here. And so if I turn the transmitter on here, you have to hold the on button on. And I programmed it so it indicates track power here. You may not see it too well in this lighting conditions. And one nice thing about the Revolution, it tells you if the linking is okay. So as you walk around your layout at maybe some distance, it'll say no link, for example, such as I can simulate by pushing this button. So, and it'll say link OK, if it indeed is linking, which it is here, of course. And it indicates what your battery is at, which is in this case 4.32 volts. I elected to use dry cells. Apparently you can use rechargeables in this thing too. And as to the control of the relay, you can go into this menu selection for auxiliary functions and select that, and you can see if it shows up here, F1 is set up for latching, and it's off right now. So if I go out of the menu mode, oops, turn it back on. Okay, so if I press the number 1 button, I can hear the relay and press it again, so it'll have it act like a toggle function. So if I press it, you can hear it click, and the green LED comes on. I press it again, it turns off. I press it again, it turns on. Press it again, it turns off. And one nice thing would have been if they indicated if it was latching up here on the display. They don't seem to. It just indicates whatever key you're pressing. If I were to press F2, you can see F2 come on all the way up to F6. But I'm not using those other ones. I'm just using F1, or key number 1 here. So now if I increase the throttle setting, I turned off the relay now. So I've set it up so it defaults into pulse width control as it goes through my terminal block here out to my tracks here. There's a Aristo GP40 on Bachmann rollers. So if I increase the speed here, I can hear the speed is expressed in terms of percent. You can see the GP40 is running, the lights are on, it's in pulse width control. So if I run the speed down, the motor stopped, but the lights are still on, which is an advantage of pulse width control. If I run it all the way down, eventually the lights go out. So in this case, I'll run it up so the lights are about a good brightness there, but the motors still aren't running, and this indicates it's 5% of the throttle possibilities, 0 to 100%. So if I keep on increasing the speed here, so somewhere around 15–14%, the motors start turning. So I'll run it a little bit faster. So I've got it set up for 20%. Now if I push the number 1 button here and go to linear, you'll see the effects. You can see the lights go out, and that's the advantage of having pulse width control, because you can have your lights and still have the loco running. Now it turns out that the motor blocks, or the wheels, are still turning in linear there. So I can switch back and forth. I normally wouldn't do this. This is just for test. So I can turn off and the lights are on and the unit is still running. So there you have it. There's the setup as I've implemented it. And again, Aristocrat doesn't supply a housing to put this stuff in. So I've ended up, basically there's only 2 holes in the main receiver board here that allow you to put some kind of screws through it. And because I'm using an old decking board, a piece of a decking board that's naturally insulated, but normally you want to make sure you insulate it if you didn't have an insulated board. And on the other end, I just kind of put washers here with screws and a spacer. I happen to put a spacer washer that's 47 thousandths underneath where you can't see in the corners. And a spacer strip of plastic slid onto this end, about the same thickness. And just washers and screws straddling it to hold it down. Did something similar on this pulse width control board, and just put plastic spacers under the custom peg board, so to speak, that I put the discrete components on for the relay driver. And the relay is capable of 15 amps DC. It's a Tyco relay. It says Potter and Brumfield, apparently Tyco took it over, took that company over, and it's capable of switching 15 amps DC, a 24 volt DC, and I think actually 30 volt DC, but it's only needs 24 here, and it's a 24 volt rated relay. And the contacts are silver cadmium oxide, which supposedly gives it that extra capability compared to if you order one that's that may physically look the same, but it would be rated less. So there you have it. The Revolution 2.4 gigahertz train engineer. For the added protection of the relay driver circuit and the fan, I installed a 1 amp fuse circuit just for added assurance there, because those devices don't really draw much current. If I relied upon no fuse, or if I elected to use a tap-off for what would have been called a sound unit in here, or sound power, which you could pick up 24 volts from that connector, that would have, taken that minimal amount of current away from the capability of the 15 amp output here, so I elected not to do that. But even if I did, 15 amps is quite a bit of current to, if something shorted out in the fan or the circuitry here, so I wouldn't want to rely on a 15 amp fuse, so I elected to use the 1 amp discrete fuse there.